Any sufficiently advanced technology is indistinguishable from magic.
Well, it isn't every day that I get to interview a friend, a collaborator, a brilliant young first-time author, a new postdoc, a postdoctoral fellow, and really just one of my favorite people that I get to collaborate with, and that now we can get to learn from, and you can get to learn from out there in the world, because she is the author of this wonderful new book from a first-person perspective from a neutrino, and that's none other than Eve Vavagiakis. I always hope I pronounce it correctly. Eve, did I do okay?
You did great.
And it's illustrated by another, a little bit unusual name to pronounce, but Ilsa Lemesis.
Yeah,
did I get it right? Awesome.
Well,
good. All right. Well, that's the end of the interview. I dropped the mic. Brian has a win. That's all that matters. No, I'm just kidding. Eve, it's such a pleasure to talk to you. You and I have been friends since we began collaborating. I've tried unsuccessfully at least 3 times to get you to come to UC San Diego, but I'm not bitter. I'm not bitter at all. But now you're here virtually back again. You'll be back hopefully this summer for our face-to-face meeting for the Simons Observatory, where Eve works tirelessly on all things experimental. And normally, Eve, we have on theorists, we have people like Neil deGrasse Tyson, Michio Kaku, Brian Greene, hopefully not too long from now. We've had 11 Nobel Prize winners, but many of them are theoretically inclined. You are an experimentalist. What does an experimental astrophysicist do?
We turn a lot of Allen keys, Brian. So many Allen keys. First of all, thank you so much for having me on. It's such a pleasure and a real honor to be amongst such esteemed guests. Oh my goodness. So thank you so much, first of all. Second of all, we get to build all of the equipment that is needed to check all of those theorists' wonderful theories, because if we don't turn our Allen keys, there will be no way to check if people are right about what they come up with to describe our universe. So I've been involved in developing these cryogenic cameras for these telescopes that are at least the ones that we work on for the Simons Observatory, and that I work on for the Atacama Cosmology Telescope and for CCAT Observatory, all down in the Atacama Desert in Chile. And when I say camera, I think a lot of people think of obviously the cameras that you hold up and take selfies with and things like that. But these instruments are practically room-filling, or sometimes high bay filling, gigantic cans of coldness that you don't necessarily think of as being cameras before you get to know them. And something else that I didn't find intuitive when I first started is the window through which the light from the telescope shines in to eventually be filtered and focused with lenses onto the detectors, the pixels of our cameras. Those windows are actually not clear to your visual sight, because we're looking at these microwave wavelengths. These are the things that we want to measure when we're looking at the cosmic microwave background. And it's funny to me to have walked into a lab and be like, but how can we see through that? Because that's not even a clear window. So working in wavelengths that you're not necessarily familiar with cameras at a much larger scale than we're familiar with in our daily lives. But it's a lot of fun.
Yeah. And you do stuff very low temperature, and we'll get into that, what you do on a daily basis. But first, we have to acknowledge the fact that we are speaking on a frigid day here in San Diego. You are at Cornell University, and that is in Ithaca, where my origin story almost began had I gotten accepted to Cornell. The 2 times I applied but didn't get in. But anyway, we're not going to talk about that. But instead, you have been there for quite some time since you were an undergraduate. Now you're a postdoctoral fellow, moving to Princeton, as I understand it, in the fall. And everyone should follow Eve on Twitter. We'll put a link to all of her social media accounts because she does so much outreach, et cetera. But first of all, Ithaca, is it warmer or colder? San Diego is about 60 degrees right now. It's a frigid February day as we're speaking. What's the temperature right now in Ithaca?
It's a little bit colder. It's not quite above freezing yet. It's around 30 degrees right now, Fahrenheit.
About half the temperature. Now, when we are building these instruments, you talked about these big, vacuum chambers, et cetera. How much of what you do is technical, turning the Allen keys, as a technician might, and no disrespect to technicians, I love them, I am one, but how much of that is driven, your career is driven by that versus your curiosity to understand the theoretical, the observational underpinnings of our universe? What's the breakdown that you maintain?
Well, part of why I joined Mike Niemack's group at Cornell for graduate school is because I was so interested in trying to go down every potential avenue I could in cosmology. So I wanted to do the analysis portion. I wanted to look at the maps that we've generated with these telescopes already. And I wanted to not just use and work on equipment and turn screws, but I wanted to design the equipment too. And it was a real gift to be able to be involved in all of the above. So I have been designing the first light instrumentation for CCAT-prime. And I've also been working with maps that have already been generated by others, hard design and equipment development work for the Atacama Cosmology Telescope, looking at maps of the cosmic microwave background and looking at, I like to call the bones of our universe, shining the CMB through these large structures, these galaxy clusters, the largest gravitationally bound objects in our universe, and learning about these structures and how our universe has evolved by using maps of the CMB. In addition to doing all the cryogenics day to day in the lab.
Some of what you do, I think of as akin to kind of like an archaeologist, an explorer, and they have to build their own tools, and then they have to travel to these exotic locations. How much of that, try to walk through your kind of elevator pitch to a young lady, young man out there who's maybe interested in science, cosmology specifically. Why should he or she become an experimental cosmologist like yourself?
Oh, gosh. Well, I would say, first of all, that you're adding in extra activities to the thinking about fundamental physics. So you can think about the theory and also participate heavily in analysis and theory work, and you can write all of the code that you want to write, in addition to understanding all of these really interesting physical phenomena down here in Earth in the laboratory. So the principles and properties of superconducting devices that allow us to make these measurements in the first place. And the sheer diversity of your daily work when you're involved in the experiment side of things is really compelling. If you're the kind of person who doesn't like to sit still in your chair all day, every day, and stare at a glowing box forever, this is much more up your alley, because I get to stand up and walk to the lab and look at something physical, and then go back to my computer and look at the glowing box again for many hours. And I really thrive on that diversity. And I think a lot of people would find it really entertaining and interesting how much variety is in a daily life as an experimentalist.
Yeah, and getting the sense of progress, when you're lost in a paper that could take years to write or something like that, or some for, as I understand what theorists do, and some of my best friends are theorists, so I don't talk too negatively about them, but it could take years to get one equation even vetted, whereas in the lab we can walk down and feel like you actually made some progress. Now, of course, we also have setbacks, and we have things that we have to encounter. As we have been no stranger to setbacks and challenges in any project. What gets you through those challenging moments when you have a setback, when you have like this part, it has nothing to do with cosmology, you ordered some part, from Thor Labs. I think you should be sponsored by Thor Labs, because you're like one of the best kind of, kind of representatives of them. But anyway, you're waiting for this thing. It's out of stock. We need this power amplifier, and you have to reboot the factory. How do you get through those challenging times where everything's out of your control and you have no influence over the outcome? As an experimentalist, that happens quite frequently. How do you deal with such instances?
Well, when you say that, it doesn't just happen in experimental life, but life in general, right? This is a daily basis thing. So first of all, you try power cycling, of course, and turning it on and off again. If that doesn't work, then you go home. No, what really does it, first of all, is hopefully all of us have experienced the opposite of that, the times where things do come through. When I was an undergraduate working on my first ever CAD design project for this little interferometer, it's a little parallel mirror translator that was going to go on the Sophia telescope, the stratospheric observatory, I've lost the entire act, for infrared astronomy. That's what it is. Yes, thank you. On the fly, literally. Seeing that come out of the machine shop for the first time, having never submitted parts, and they actually fit together, and it was actually the shape I wanted, and it actually did what I wanted it to do. The thrill of that is always in my mind. And so I have things to look back on, former successes that I can look back on and say, okay, literally nothing is working this day, week, or month, or maybe year if you're having a very bad year. But things have worked before, and you have to have faith that things can work again. And I think life comes in waves, as does work in the lab, where you'll have successful times and you'll have the not so successful times. And it's a sheer product of the not successful times that you have any success in the first place at all. So it's almost a prerequisite. So when things are going poorly, it's kind of like when you're climbing up a hill on the bike. You have to go up that hill in order to go down the hill. You have to go through the difficult times where your data doesn't make any sense and the cable fell apart for the 1,000th time and you don't have time to solder it and you have to anyway. You work through those knowing that is that needed to happen to have your success happen in the future.
And, the challenges, as you say, happen inside and outside of the laboratory. But in terms of like what keeps you going on the most macro level of all, describe to my audience what fascinates you the most about the cosmos specifically. Because you could be you're like Liam Neeson, you've got a particular set of skills that are, deadly. No, they're not deadly, but I don't know. But you could be doing anything. I mean, you're incredibly well-rounded, educated, and you have talents ranging from computer programming, statistical data analysis, machine learning, and also unique experience with low temperatures as low as a fraction of a Kelvin that you can routinely do, and it's a very rare skill set. What caused you to turn this intellectual capital specifically in this direction? What fascinates you the most about cosmology?
So when I was an undergraduate thinking about what I would like to study, I went into college knowing I wanted to do something with astronomy, something with space sciences. I was always very interested in space as one of the final frontiers. I either wanted to study space or the brain because I thought that those two were just enormous, compelling spaces that had so much wealth to be discovered. And the more I learned about physics and astronomy, cosmology was a way for me to be intellectually greedy because it's literally everything at once. And what could be more compelling than literally everything all at once? To think that I, as this small creature, this meat machine that is on this little space rock flying around in a nondescript part of the galaxy, by design, right? If it was too exciting here, we wouldn't be able to be life form. So it's actually quite boring. That I can look out and devote my professional life to studying the entire universe every day, that gets me out of bed. I love thinking that I can contribute in my small way to the knowledge base of humankind. And if I'm not going to do that, then I would want to do something that helps people personally. Sometimes I do feel a little bit sad that my efforts aren't going to a tangible putting, a real smile on people's faces. And that's where my educational activities come into play. I feel like I can use what I'm doing to try to push along our little bubble of human knowledge. I don't know if you've seen that graphic of a PhD, which is like this enormous discipline, and then you're just carving out the tiniest little poking out into your knowledge sphere. So not only am I working on that on a very compelling topic, but that I could also translate that into helping other people discover that not only could they go into STEM fields or go into physics or go into something like what I'm doing, but simply that big, challenging topics that are intimidating are fields in which people can go and contribute to, and in fact are needed in. And society needs everybody to feel like they can access what they want to access and give what they can give. Mm-hmm. So that's my way of trying to translate the whole I'm studying the whole cosmos thing into like I'm helping people. That's what I'd like to see.
And I talked recently with another author. His name is Geraint Lewis. He's written a bunch of books, and his latest book is about it's called "Where Did the Universe Come From?" and is written by a collaborator, I think Chris Corey. And they wrote these books, Astrophysics for Babies, and all sorts of other books that I love and my babies love. But he said the neutrino is the most interesting object in the universe. And now, and I don't know when that interview will come out relative to yours, because today one of the main goals that I have is to expose as many people as I can to this book. And whether you've watched or not past episodes, one of my favorite things to do is a segment that I call Judging Books by Their Covers. And that's when we do what you're never supposed to do, which is to judge a book by its cover. But with a first-time author like you, or when I wrote my first book, what else can you judge a book by? You see it, you get some word of mouth perhaps. But talk to me about this book, and it's published by MIT Kids Press, which is a delightful imprint, and I've been grateful to get to know some of the folks at MIT Press. But this is my first children's book that I featured on the show. Now, for my audience to play judging books by their covers, what is the origin of the title, and what are these mysterious, whimsical characters on the cover meant to represent?
So I think the big news story here is we've discovered that neutrinos are fuzzy, cute little creatures. So I'm a Neutrino came about after one of my particle physics classes in graduate school, where I had just joined Mike Niemack's group, and I was thinking about these big questions we can address with cosmology, and specifically what big questions I could be tackling with my research. And one of the things that surprised me was that we can use the cosmic microwave background to use the entire universe as a laboratory for particle physics, which excited me because I was also interested in particle physics when I was an undergrad thinking about what I could do in grad school. So I'm like, I can do both. That's fantastic. And so we really can use the CMB, and specifically the structures that the CMB is backlighting, to learn about how the universe evolved over time. And one of the sneaky things that neutrinos got up to early in the universe's history is that they took some of the mass that's in the whole mass budget of the universe and just flew around with it. And they didn't cluster down like the rest of the friendly matter down into these gravitational wells. Instead, they just kind of flew away like little mass bandits. And so they washed out some of the large scale structure of the universe. So as I was learning about the physics behind these little particles that took the mass away, I was really compelled by the notion that we are just learning about these neutrinos pretty recently. They weren't originally understood to have mass at all, and it was only this odd behavior that they display with their oscillation, meaning at one point you pick a neutrino up and you say, oh, that's an electron neutrino, and a little while later down the road as it's flying around with this little mass, you pick it up and oh, now it's a tau neutrino. And they're very curious little creatures. So my whole life I've always just written down poems. That's just a feature of me, is I'll get hit in the head with a poem and just write it all down. So I got hit in the head with a poem after one of my particle physics classes and just wrote down a poem, and it started with, hi, I'm a neutrino, and I am so small that matter to me barely matters at all. And I sent it to my mom because I sent her all my poems. And she said, wait, this would be a great children's book. She's also in the publishing industry. She's a professional artist, and her name is Ilse Lemesis. She's the illustrator of I'm a Neutrino. And so we started working on this project together, and she came up with this cute concept of these little fuzzy neutrino friends that I would not have thought of, because I think most particles are depicted as little spheres. But they don't have to be spheres. We're not going to be able to take a picture of them, and we're not going to be able to see them, and they can be fuzzy if we want them to be fuzzy. So that's what we did. And this cover depicts a whole bunch of colorful flying neutrinos in this swirling background that I really enjoy, because it's space, but it's abstract space. And I think that the cover joins the tiny with the very large.
Yeah, to me, it's kind of evocative of the other moniker that these particles have, which are ghostly particles. Why are they called ghostly particles even?
So we don't interact with neutrinos very often. These little, and I almost want to call them creatures when I'm looking at them on the page, because they're sort of animalistic. We can make them into creatures in our mind, but these particles don't interact electromagnetically, which is how we're looking at each other right now and how we interact with a lot of the world. They have a tiny, tiny mass, and they only interact through the force of gravity and through the weak force. And although they're one of the most numerous particles in the entire universe, they're streaming through us all the time, and we just can't feel them, can't see them. They're harmless. They don't interact with our cells. The weak force only interacts on very small distances, and they do not bother us, and we don't see them. So they're ghostly little friends flying through us constantly. Or maybe we know what they feel like. We just are completely immune to it because it's happening all the time. No, but we can't actually feel them. But that's another thought, right? Because we wouldn't know, because it's always happening.
Now, I happen to have access to some children, and they are on loan. No, they're on loan from heaven. But actually, they really dove into this book. So I would say the target audience for at least an informal survey of my household ranges from about 7 years old at the younger age, all the way up to 12 perhaps on the upper age. And maybe there's no limit, because I actually think it appealed to me because the illustrations are so whimsical, and your commentary, your poem is so delightful, and it's evocative. And it kind of reminded me of a fellow Cornellian, I think is how you say it, and that's this guy, Carl Sagan. So Carl Sagan had many aphorisms and great contributions, both in science and hardcore science, like you practice, and also in communication to the public. And for that, I think he deservedly gets a lot of great attention. But it didn't come naturally. And he actually got a lot of criticism. And I don't know if you know this, but he was not elected and inducted into the National Academy of Sciences, even though he made tremendous strides. We know him because 1 billion people at the time saw his Cosmos series. But he was also a phenomenal scientist. He was one of the pioneers of what we call astrobiology and what are called extremophiles, as well as being, a world-class planetary scientist and working for NASA, designing. And one of the things he did was command the Voyager 1 spacecraft on Valentine's Day, 1990, to take a picture of the Earth, and it's called the Pale Blue Dot. And we can put the poem up here, and it's really evocative. But in so doing, he took a lot of risks. And I'm wondering, when he was criticized, he heard things like a serious scientist doesn't do such things and nowadays he'd have a podcast like me, and he'd get criticism from his department chair for spending time on non-scientific related things. I do some other things, as you know, but a real scientist should do. But how did you overcome the barrier that most of my colleagues will say as to why they don't outreach as much to the public? And that is, I'm not good at it and it's hard for me. How do you overcome that personally?
So the reason I'm hesitating to answer that is because I think it's been the opposite for me. When I first started studying physics, that was hard for me. That was something to really overcome. I needed to work very hard to understand the upper level courses that came more naturally to my peers, whereas I've always been excited to communicate about whatever it is that I'm doing. I worked in my local library running children's summer programs for 6 years in middle and high school. And really, any topic that I pursue, I love to communicate. So I think I would approach the answer to that kind of in the flip side, because for me, it was very hard to learn to do the math that's required for my physics courses. And how did I get good at that? Well, practice, right? You just need to do it. And there are moments in life when you start a new skill that there's a suffering that needs to occur for you to get good at anything that you're trying to do. That initial feeling of discomfort, of I'm out of my comfort zone, or I don't know if I should be doing this, I don't know if this is for me. You look to your left, you look to the right, everybody else is seeming to do great, and you're just kind of floundering. The imposter syndrome, but that feeling I've now been able to associate with that's awesome. That's day one. That means you have so much you can learn and so far to grow. When I don't have that feeling, I get a little concerned because I feel like, okay, well, I'm not learning any new skills. I'm stagnant at this point. I want to feel uncomfortable again. So if you can lean into that discomfort and keep practicing whatever it is that's difficult for you, you'll get better. You're going to get better because the more you do something, the easier it gets. And as long as you think it's worthwhile, I think that's the key. You need to find it to be worthwhile. You can't have everybody breathing down your neck saying, this is stupid. Why are you outreaching with the public? But I hope that has been changing in departments, and we're seeing the merit of this.
Well, one thing, that you tweet about, write about, and particle bytes and other things that you work on is representation in physics, issues of equity, diversity, et cetera. And you do so in a very ecumenical way, perhaps is the right word. You're not, chastising, but I think you're an optimist. You are encouraging folks to get into it. Undoubtedly, I would prepare myself if I were you. I'm not being patronizing in any way, but I think there are going to be a lot of parents that are going to ask you, first of all, Eve, how do I get my kid, boy or girl, interested in science? STEM is the future of the human race. But then from a lot of women, they might say, or about parents of young girls, they might say, how do I encourage, especially my daughter, to get involved in science as you did? So, do you have any? I don't want to say like tips, tricks, and hacks. One weird trick to get a PhD in astrophysics from an Ivy League school. No. But how? And it sounds like you weren't like the perfect SAT score, perfect GRE score person. Neither was I, obviously. But I think there's this notion that you have to do that. But how would you recommend? Not necessarily what did you experience, but what would you recommend to these many thousands and tens of thousands of parents and a lot of young people that are listening to this podcast as well? What's some of the ideas that you have to promote both growth of STEM for young people in general, but also for women specifically?
Yeah. So my definition of equality will be not when we achieve a certain quota in every field or that we get all women interested in STEM. I think it's more along the lines of, I want every child to feel like whatever they want to do, whatever they're interested in, they can have access to learn about equally. You can learn about any topic you're interested in. You're not being held back from any topic specifically, and feel that there's a path forward and a belonging for them in that field. So I'm very excited about getting women into STEM, but I am overall most excited about getting any child into any field that they want to contribute to, because that to me is true equality of access. For STEM specifically, I think a few barriers are in place, and the parents who are going to be coming to me and asking me what they can do for their kids are already doing great, I would say, because many, many more parents don't even know that this is available or are poo-pooing it to their kids actively. I was actively disincentivized from my family, actually, to go into physics. I'm from a family of musicians. I'm one of the only scientists, and I was actively encouraged to not go into a field that was so incredibly boring. So there are parents out there who are saying, don't study that. That sounds so dull and terrible, and I want you to be a charismatic young person. So the parents who are already interested in this and are buying this book for their kids are already doing fantastic. For young people looking to get into this field specifically, I think part of what I'm trying to do with this book is convey information about what experimental life is actually like. I think there's just a knowledge gap between early education and active modern research that even the undergraduate students at Cornell in our own labs don't know, for example, that graduate students receive stipends. They don't need to take out extensive student loans to get a PhD. This is something that is not widely known. You do not have to be rich to get a PhD, like you need to take out loans for med school or for law school. I come from a family that could not have taken out loans for those types of degrees, and I couldn't have been here if it wasn't for that. And I think this knowledge needs to be conveyed. So anybody with a keyboard and an internet connection, I highly recommend spending some time to look at the nitty gritty. Like, can I afford it? Where will I go? What am I going to be working on? And that's what I want to start to provide some clues for the very youngest children out there, because it starts early, and you need to know what paths are available for you to even take before you take them.
Yes, very good. So now we mentioned earlier that no path to the heavens is direct and straight. It always comes with challenges. And I wonder, if part of the, bias that we have and seeing, everybody as either Einstein or nothing is that we don't talk about the setbacks, the challenges as much. And I wonder, if you'd be willing to kind of, talk about some of the experiences that you had. My advisor, Peter Timby, past guest on the show, everyone always accuses me of name dropping. Oh, you're just name dropping Neil deGrasse. Well, no, I'll also name drop Peter Timby, who's got zero social media. But I want to ask you, he used to tell me that if you don't consider quitting graduate school at least once, maybe once a year, maybe he was trying to encourage me to leave. I don't know. But if you don't, think about leaving at least once, then you're not really getting the full experience of being a student. Talk about like a challenge, a low point perhaps that you fought through. And this kind of dovetails with one of our final closing questions that we'll get to in a few minutes. But tell me, Eve, was there a challenge that you are particularly interested in sharing, such that it might be a teachable experience for those students, graduate students, of which there are many, many, many that listen to this podcast.
Yeah. Yeah, I'd like to share, I think, the early story of my health challenge and how I ended up transferring graduate schools early on in my career. And this isn't something that I talk about a lot because it is a bit personal with health struggles, but I think it's important to talk about this type of struggle because there are so many health challenges out there, but also because there are just so many challenges out there and people don't hear about the way things can go wrong in graduate careers as much as you hear about the typical stories. So when I graduated from Cornell as an undergrad, I went to Caltech to start my grad school career. And I have really severe asthma that reacts terribly to air pollution. Little did I know the Los Angeles area has some of the worst air pollution in the country. And it got me pretty bad. I developed bronchitis within my first semester, and I had already had a history of that. So it really took me down, and I ended up on some powerful medication for that gave me such severe Achilles tendonitis that I ended up in a wheelchair. And the doctor advised me that I should not spend a lot of time outside, period. And so I was in a wheelchair. I couldn't drive myself to my lab anymore. I really couldn't get involved in classes or social life or my work. I couldn't be my best self. I could barely be myself at all because I couldn't walk to the kitchen. And I really faced a reckoning at that point of realizing I could not continue in the area because you need to walk to do experimental physics. So I ended up transferring schools, and I had a choice of a few schools to go to, but I chose Cornell in large part because of the diversity of cosmology work that I could undertake there. And I am so happy that I ended up doing that choice, even though it wasn't very traditional, because it landed me back at my undergrad institution, where I still am as a postdoc, right? So it's not traditional of a course, and I certainly had to question whether my health was going to keep me back from attaining the things that I wanted to attain the most. And I really needed to focus a lot on building my physical health back up to do the things that I wanted to do. And I think I chose to stay because my desire to contribute in the way that I felt I could if I hadn't had these challenges keeping me back was so strong. And I did not want to see a limitation that I did not choose for myself destroy my dreams as a person. And I am so glad that I had the, determination to try. I didn't know if I was going to work. I couldn't stand long enough for my toast to toast. I needed to work back up to walking. I needed to work back up to doing this work. And talking about into the impossible, if I had seen where I am today, and I just completed, actually last October, my first Imperial Century on the bike. I biked 100 miles. I would not have thought that was possible. So I am so glad that I persevered through that. Now, this story is not to say that grad school is the right choice for every person, but it is to say that if you are determined to do something and you're facing a real hardship that might not be of your choosing, if you're going through financial troubles, family troubles, health troubles, and these things are keeping you from what you want to do, but there's a glimmer, there's a crack. The line in the song that says there's a crack in everything, and that's how the light gets in. As a cryogenicist, I say that's where we put aluminum tape so the light doesn't get in anymore. But there really is a crack in all things, and you can exploit that if you are determined enough to take the next step and the next step and just see what happens. And so I always said that I'm going to continue in physics until somebody kicks me out. Nobody kicked me out, not even myself.
Right. That's great. So then I think, one thing I never like to do is to, summarize the book completely. And especially with like audiobooks now, people will listen to them, and I don't want to give away kind of the goods. Now, this book is a quick read, even for a young person, but I think it's quite deep. But I wonder, if you wouldn't mind maybe just reading maybe one passage or something, maybe even the first couple of lines, and I'll show the pictures as you're reading, if you don't mind, or if not, if you don't want to cannibalize book sales. No, I mean, everyone should get this book that has a young person, or if they're just interested in it. So maybe you could pick a line and then you'll read it, and then we'll open the show with you reading from this wonderful book.
Okay. And you have to tell me what your kids think of it, because I'm dying to hear. You started and then you never told me. So I'll read. I'll make the bargain with you.
Maybe I'll get them to open the show with their live reads and their reviews.
Oh, that would be
they loved it.
fantastic.
They summarized it perfectly, and they kept saying about how these things are they prove that ghosts are real. So I think that, just as I'm trying to get them to go to bed, Eve, thanks a lot. It's now they're terrified about ghosts being not those kind of ghosts.
No.
These kind of ghosts, these fermionic ghosts. So pick a page, and I'll show the illustration as you talk, but only one page, please.
Okay. Well, can I start with the beginning, and then I'll go one more page into it, because I've already said the opening line. Okay. So it says, "Hi, I'm a neutrino, and I am so small that matter to me barely matters at all. I am a particle, like electrons and light. I can pass through you without stopping my flight. I'm electrically neutral. I don't have a charge. And with my small mass, I don't feel very large."
Well, I love it. It is now, when someone has a kid, now it's my go-to gift, which parents, they'll either appreciate that or like a 529 savings bond. So my kids love this book, and the two that are able to read on their own, at least, and they accurately summarized it. And now I think the most exciting thing is that it really generates new ideas for them. So one of them was talking about, could you use neutrinos for energy? And I think it's important, because this book, one of the descriptions that we get as authors, rather as podcast hosts, they give you a little blurb from MIT Kids Press, and they talk about how the message of the book, in part, is to inspire kids that they too can become scientists. So anything that evokes a question or a puzzle and maybe can't be answered. I mean, that's the purpose of grad school, right? So I think that's the highest encomium that you can get, that these kids are inspired to ask questions, and maybe it will lead to an interest in science. And I think it will definitely lead to an interest in science. Maybe it'll lead to a career in science. And I'm just going to say this. I don't need a response from you if you don't want to, but I think most parents would be really thrilled if their kids became scientists. I don't think there's a parent who says, "No, like I absolutely don't want my kid to be in STEM or STEAM," as they sometimes add to it. Because this book really is a work of STEAM. So feel free to respond. You don't have to, but I think it's an ideal lifestyle. The life that you and I have is one of intellectual rigor and pursuit and scholarship, and I think that's the best reason to do it. We could be both doing stuff that's more profitable, but we enjoy it, right?
Yes, and I'm so excited to hear that your kids are coming up with these questions, and that's why in the back of this, it's not just a poem, but for every image that accompanies the poem, there's a learn more section that talks about the physics that is behind this. So the statement, with my small mass, I don't feel very large, like that's cool, but what does that really mean? And you flip to the back and you start learning about it. And then there are other resources that the kids can dig into more and learn about. So I'm hoping that this is a mild introduction through the nice prose. You can just read it if you want to, or you can dig deeper into what the experiments actually are. And for your point about the lifestyle of a scientist, and how kids can get interested in this, I would say, what is more childlike than looking at something and asking why? Right? Yeah. That's all. The kids are scientists. Every child is a scientist. Every baby, when they're watching an object falling, is a scientist in that moment. They're a physicist. They're doing physics in their mind. And so I feel very childlike a lot of the time in the lab and in our work, where we'll play with these giant toys that we get to put on these ridiculous telescopes. They're just like, it's real life Legos, right? And it's Legos with a purpose. And that purpose is to investigate some of our biggest questions that are now adult-sized questions. But we've been asking this all along. And I'm sure you two have stories of being a little kid and coming up with little sandbox experiments and stuff growing up. So I'd say being a scientist...
Portable nuclear devices.
Being a scientist is there's a lot of play, and the intrinsic curiosity in our discipline is childlike in a really positive way. So yeah. I'm really happy to be a scientist.
Yeah, it's wonderful. And of course, as parents know, the ultimate question after you get this chain of whys, why does the neutrino have to load us? Why does the neutrino go through matter? What is it? The ultimate question can only be answered with the final answer, because I said so. And that's not maybe the most scientific thing you can say, but actually it gave one of my kids a chance to bring out some of his astroparticle jokes. And I wonder if you've heard this. Do you know the photon gets a lot more attention than the neutrino until now? Now the neutrino is going to like, what's a photon? But the neutrino. Oh, one of my kids was like, and this is really fun. He got really patient. Like, do you know it's basically like a neutron except it has almost no mass and it behaves just like a neutron? In fact, they wanted to call it a neutron, and he was just like getting into it. It was so funny, so passionate about it. But then he broke out his astroparticle joke. Why don't photons carry luggage? Do you know why?
Why? Does it have to do with it being not very light?
Well, no. So photons don't carry luggage because they're traveling light.
Ah!
They're traveling. Feel free to use that. Feel free to use it.
That's fantastic.
It's almost as good as I had Delilah Gates on over the summer last year, and I asked her, do you know why black holes are so skinny? And have you heard of the black hole diet? And she said, no. And I said, yeah, you just eat light. These are the dad jokes that mix with astroparticle jokes that now you can use for your benefit. Okay, Eve, we've now reached a segment of this podcast where we go into the impossible with the thrilling 3 final questions. Let's ready to go. I'm really breaking out all the accoutrements.
So excited. And if you're just listening, I'm pumping my fists. You can't see it.
She's pumping, and she has been to the gym. She puts her workouts on the Twitter. I always love that. It always makes me feel like a real slob. Thank you, Eve, for inspiring us elderly senior colleagues to get back to the gym and rock climb. You're a rock climber, right?
I do like climbing, yes.
That's awesome. Where are you going to go in New Jersey?
Oh, well, I'm only going to be going to Princeton in the last year of my fellowship. So for now, I'm going to keep exploring the Finger Lakes. So I don't know, but I'm sure that you know what I would love to do is get back into aerial arts, because I went to the circus school here briefly, and that was really fun. So I bet the Princeton area has more resources for aerial art stuff. So
it probably does. Okay, Eve, as you know, we like to talk about the deepest existential questions on the show because I think as scientists, we have our own unique perspective on the meaning, the purpose, the value of different things about our lives. And so I like to share this dimension of my guests with my audience. So the first one has to do with your future, 90, 100 years from now. And that's involves what's called an ethical will. It's not your monetary will, which as a grad student and postdoc is really replete with riches and Bitcoin and no, I'm not assuming that. But I want to ask you, when you reach the age of 120 years old, which is 5 factorial, as you know, when you get to that biblical age of 120, what wisdom, not material bequeathment, but what wisdom would you hope to convey to those that come after you? To stay out of LA. Stay out of LA. I told you, San Diego is nothing like LA.
Yeah, going back to your gym comment a little bit, I think that there is so much merit that isn't highlighted very often, but needs to be in developing the foundations required for these higher successes. Your health, your physical health, your environment. These things are required for you to do anything that you want to do. And as a society, our collective health, our environmental health, not living in polluted places, having access to clean water, not being in a war zone, having ability to not have your mental space taken up by where you're going to get your next meal or how you're going to manage your rent situation or your household difficulties. Focusing your efforts into helping each other and helping your own self develop a strong foundation is the only way that you can start to do the type of science that brings all of your listeners to this podcast and the type of higher level intellectual pursuits that we can accomplish as a society. We need to focus on the basics that get us there in the first place. And it's easy to not go to the gym. It's easy to not clean your house. It's easy to try to focus on the and I know I say that speaking personally. I sometimes skip these things. It's really important to maintain not just the trivial aspects of cleaning your living room and doing your health, but from a societal aspect, it's easy to eschew the smaller things in favor of the immediate reward. But we really need to foster a healthy society and a healthy self in order to get where we want to go, collectively and individually.
Yes, wonderful. And the second question also goes into the future, but this one a much further future, a billion years into the future. And it's sort of based on this movie, 2001, A Space Odyssey, where there are these monoliths, these kind of menacing objects. Maybe they're time capsules, maybe they're warnings, maybe they're just kind of like trophies or something like that. And it really made me kind of think about what would we most want to encapsulate what humans have learned about in your field, which is also my field. But what would you put on a billion-year lasting time capsule to tell our future alien inhabitants about the glories, the wonders of what humankind has accomplished in the scientific realm?
Well, this question is interesting because as academics, we publish our research, right? And if the answer isn't what you're publishing, then why are you publishing? Right? So in some part, what I'm publishing, no, it'll just be the archive. No. um, yeah, jokes aside, well, first of all, I hope my research is somehow useful, and that's one exciting thing is that realistically, I'm not going to build a billion-year monolith probably, but realistically, I will be leaving behind the things that I am publishing, and so that's one nice part of what I do is I feel like I am building a small tome of information that hopefully will help future people. But on a larger scale for the whole planet and such, I'm not sure my particular research speaks for all of humankind for all of history. But I think I would probably do something like an Earth's black box, where I like to think about the Fermi paradox, right? Which is why, having it be statistically likely that there are intelligent life forms out there that should have reached us by now, have we not heard from any? And there are a bunch of theories as to why that might be. One of those theories is that maybe civilizations destroy themselves before they can make enough progress to get out there and interface with other civilizations. And I hope we're not going that way, but right now it doesn't look super great for our planet and our longevity unless we change our perspectives and our motivations as a society and really help this environment. So I think I would encapsulate everything that happens into a black box like those on aircraft as they crash. Hopefully we don't crash. It would be great if we don't crash. But if we do crash, having a record of what happened and how we got there and the rich diversity of biological life on this planet and all of the beautiful things that we have around us to appreciate right now. I draw a lot of inspiration from the natural world, and I spend a lot of time outside, both in my career and just my personal life. And I think writing or encapsulating that somehow into this black box, everything that was and that might end or not, hopefully, we'll see. That would be useful for the civilization that finds it because clearly they're still kicking and I wouldn't want them to encounter the same problems that we have. And so if they could learn something from our experiences, we might help with intelligent life in the future. So I'd like a black box.
Okay, that's wonderful. Just don't have it be a CD-ROM or something like that.
Yeah.
Don't require, like an SD card reader. And the last question now, instead of going into the near future, the far future, is going to take us to your past. For you, because you are younger than the average guest on the Into the Impossible podcast, I'll only ask you to go back, say, 10 years, 15 years, half your current age or approximately thereof. And I want to ask you, along the lines of what Arthur C. Clarke said. He said, the only way of determining the limits of the possible is to venture a little way past them into the impossible. And I want to ask you, what would you tell as advice to your former self to give her the courage to go, as you have gone, into the impossible? What advice would you give to your former self?
I love this explanation of your podcast name, and this is how I feel like all of my life has been. It has been repeated steps into the impossible. I often climb large hills, but one of the times I climbed a large hill, I thought to myself, wow, I'm approaching this hill. I have no idea how I'm going to get up the hill. I cannot see a path up the hill. I don't even know if it's too steep, if I'm going to fall off the thing. But you take one step and then the other one becomes obvious, and you take that step and then another one becomes obvious, and you just continue, and then you're up the hill and you're like, wow, I didn't see how I was going to go up that hill. That's how the past 10 or 15 years of my life have gone. You do one step with the best of your abilities at the time. It might be really small. It might feel like it has no impact on the next 10 years. You might not be able to see the path forward whatsoever at all. And little me, and me now, honestly, has trouble having faith in that next step. I think if I could go back and talk to little me, I'd be like, you can find the next one, I promise. And it really is. Every step into the impossible leads to another step into the impossible until everything actually was possible all along. You just can't see it. And I would really appreciate having just known, like, no, you should just keep stepping. Like, you got this.
Keep on going into the impossible. I love it. That's beautiful, Eve. Well, we've been talking today with a longtime friend, but first-time author, Dr. Eve Vavagiakis, who has written this book with Ilsa Lemesis called I'm a Neutrino. And it's a first-person perspective that gives kids an up-close and personal introduction to both the beauty of science, but also a taste of what it feels like to ask questions, which, as Eve said, it's really the core of what it means to be a scientist. And to do as we recommend on this channel, my motto is ABC, always be curious. And I think this book has the highest praise, the testimonial from both me and my kids who enjoyed it, that this is such a lovely contribution that will really stoke the imaginative fires and keep the curiosity alive. Eve, thank you so much for joining us on this cool, frosty, late winter day in Ithaca. May it warm up soon, and may we see each other again in person here in San Diego this summer, if not before.
Thank you so much for having me, Brian. This has been wonderful.
Any sufficiently advanced technology is indistinguishable from magic.
If you like this video, check here for a playlist that I created just for you.